Hello, good morning, ladies and gentlemen, all engineers enthusiasts. It's December 4th, and that means the last webinar of StatiCa is on, and it is about how to take the reinforcement in concrete blocks into account when you design anchoring. So welcome everybody. Let's introduce ourselves today. Who's going to present? So it's me, Adam. I'll be the moderator today, and I have Ondřej Hudec with me, a colleague of mine, a product engineer in StatiCa. Ondřej, are you with us?
I'm here with you. Thank you, Adam, and hello, everybody.
All right, and a second speaker is Dominik Baric. Dominik, how are you today?
I'm great, Adam. Hello, everybody. Hello, Teet.
All right. We have our favorite user, Teet, today as well in the attendees list. So let's continue with the introduction. We are running on the platform GoToWebinar, and that means by default you are muted. But if you are interested and we ask you to be so, please ask questions during the webinar, type them in the questions panel, and we will answer them during the webinar. We will write you back, and we will read loudly at the end some of them and answer them at the end of the webinar. All right, so questions panel, feel free. And the agenda. So obviously we are going to talk about anchoring, designing of anchoring in concrete blocks. And in particular, so we will try to answer questions and deal with problems such as why to analyze or take into account reinforcement in concrete block and designing anchoring. How does the workflow look like in StatiCa apps? What means the 3D solution in detail application? You will see a practical demo of this whole workflow and some tips and tricks for the correct modeling and how to avoid mistakes. So that's pretty full agenda. Let's start with that. But before, there is the first poll. So let me run that. A question for you. So how often do you deal with anchorage when you design anchoring that fails the code check due to concrete failure? So the anchors are okay, but the concrete doesn't fulfill the code criteria, and you need to do something about that. So the poll is open. You should see that on your screen. If you can't click, just maximize the screen on your monitor, then it will allow you to vote. The vote is still in progress. Ondřej, you as an expert engineer, a former structure engineer, dealing, of course, also with anchoring and concrete blocks and foundations. Was this an issue for you?
Well, thank you, Adam, for calling me an expert. But I can confirm that in my years of working as a structural engineer, I encountered this problem quite often, and it was not always easy to solve.
All right, so your vote is often. Thank you for that. So let's see about what you say. So now you should see the result, and yeah, it pretty much corresponds to what Ondřej said, almost 60%. That means often, 36% of you say sometimes. So you are in the right place to hear today how StatiCa can help you with this problem. All right. let's hide this poll and continue in the presentation. So I will just start briefly with the ultimate question: why? Why do we try to solve this problem in IDEA StatiCa with our software? Why to even deal with this at all? So, introduction. So, when you design anchors into a concrete block, there are multiple failure modes as described in the Eurocode. Some of them are purely about the anchors, such as the steel failure of the main anchor, and some of them deal with the concrete block, such as the pull-out and breakout. All right, and actually these concrete breakouts are very often the critical failure mode when you design anchoring. So the whole design fail with this criteria. So this is a critical and important fact in the design of anchoring. How to avoid that? First option is, if I go first back, is that you just make the concrete block larger, deeper, and bigger overall. All right, so that sometimes helps, but it's of course not economical, and sometimes you even cannot enlarge the concrete block. You are limited in space, etc. So the second solution is to insert reinforcement. That usually is there already, right? So the code here says if you insert the reinforcement, that prevents the concrete breakout, and you don't have to deal with that. That's fine, that's very good, but it also says that you have to design this reinforcement, this supplementary reinforcement on the forces that arise from the anchoring that are transmitted through anchors to the concrete. So now there's a second problem that you have to somehow calculate these forces and take them into account when designing the supplementary reinforcement. All right, and another fact is that there is already the reinforcement for the concrete block itself, right? So you don't have to, or usually you wouldn't need to add any more supplementary only for the anchoring. So you would use the existing or the reinforcement that is designed to reinforce the concrete block itself, right? But how to do that? Again, Eurocode says that you can do this, use this reinforcement as a supplementary for anchoring as well, but there are, again, no instructions on how to do that and how to calculate that. So that's the problem. Why to think of it, why to deal with that? That's our motivation to help you with our software. Another one, another motivation or problem is that when you have a group of anchors that are close to each other, so you have the common concrete cone for multiple anchors. Again, this case is not very well described and covered in the design code. So you somehow have to estimate or deal with that. This is all like a big problematic topic that we picked up some time ago, and we brought a solution. That is the 3D model in detail application. And that allows you to solve this failing anchoring due to reinforcement or unreinforced concrete block, these group of anchors that are close to each other, and when you design anchoring into existing concrete block with reinforcement already installed. All right, so to sum it up, why we bring this 3D solution in detail: we want to give you a quick and effective tool to deal with these reinforced concrete blocks and anchoring, to calculate the overall capacity precisely, deal with these problems that are not perfectly covered by codes, and give you the possibility to deliver code compliant and safe outputs and reports in your projects. All right, that's for the intro, and I will now give the presenter to Dominic that will show you the workflow and explain you how to use the application to achieve what I have just introduced.
Thank you, Adam. I'll just ask if you can see my screen.
Yes, I do.
Awesome. All right, thanks for the intro. And let's jump into the introduction of the complete workflow of the anchoring design that is now possible with StatiCa. In StatiCa connection, you might deal with anchoring close to the edge or multiple groups of anchors, and receive the failure of anchors, and that is due to the plain concrete. That's why the 3D model type was developed for the detail application, and when dealing with anchoring, the reinforcement is taken into account, elevating your design. So how does it work? You start in StatiCa connection, design your anchoring, analyze it, and you are faced with the failure of the anchors. There is a button where you can export your anchors, base plates, and load effects into StatiCa detail. There you can reinforce it and calculate it, analyze it, and you will receive the complete anchor checks, hopefully passing your design. Together, both of these applications cover all failure mechanisms for anchoring in reinforced concrete. And with that, you can cover all of it, as I have mentioned. In detail, the steel failure, concrete cone failure, splitting failure, and in connection, the pull-out and steel failure on the lever arm. Now, I have prepared a series of questions and answers to explain the differences between connection and detail application. The first one, in connection, the concrete is the first question: how is the design of anchors and concrete carried out? In connection, the concrete is considered as plain, unreinforced concrete, and all of the checks are carried out as empirical formulas stated in the code. On the other hand, in detail, the concrete block is reinforced. In fact, it must be reinforced, and the block and reinforcement is modeled as finite elements. It utilizes the method called 3D CSFM, which I will explain later, and all of the materials are fully code compliant. Question number 2. How is the concrete block modeled? Well, in connection, in reality, there is no block at all. In fact, it is only a visual representation. Rather, it is modeled as a Winkel subsoiled model, which provides the stiffness of the concrete block, only allowing for the transition of compression. And the contact stress is calculated according to the formulas and averaged over the effective area. On the contrary, in detail, the concrete block is modeled as a 3D finite element. The triaxial stresses are considered in the characteristics of the material. And as a result, we will receive the equivalent principal stresses that are compared to concrete strength in compression. Third question, how is the load exported? I have mentioned that the components together with loads are exported from connection to detail. So how is the load export carried out? In connection, the load effects acting on the shell elements are equivalent to the internal forces received in FEA software. With that, we receive the equivalent stresses on plates, forces in anchors, and contact stress in concrete under the base plate. This is what we export into detail application. However, in detail, the method is a bit different as we are in the 3D. Therefore, the stress in welds is exported as a group of forces in lines that are mirroring the shape of the column. And the forces in anchors are exported as pairs of forces. First, there is a tension force acting in the anchor. And secondly, there's a compression force resulting in the opposite direction. Ultimately, together, they are maintaining the equilibrium. Last question. Is concrete considered cracked or uncracked? Well, in connection, you as a user can decide if you consider the concrete cracked or uncracked. You can modify this in the project settings. You will find project settings under the icon of the cogwheel. And here you can check or uncheck if whether or not the concrete is cracked. And in detail, one of the assumptions implemented in the 3D CSFM method is that the concrete is neglected in tension. Therefore, it depends on the value of the loads whether the concrete will crack or not. The app will calculate this for you. Well, that was the last question of my mini series of questions. And now, I have mentioned the term 3D CSFM many times already. Let's have a quick look at what it is. The method of 3D CSFM is implemented in application idea StatiCa detail, which is not a new application. However, what is new is the 3D model type powered by the 3D CSFM. The method is a nonlinear finite element calculation method capable of considering reinforcement in concrete. The CSFM stands for Compatible Stress Field Method. The CSFM principle can be explained using a 2D plane stress element in a reinforced concrete structure. The picture on the left illustrates this element under horizontal normal stress, sigma x, vertical normal stress, sigma z, and shear stress, tau, as typically demonstrated in elasticity classes at universities. These stresses, often derived using finite element analysis, are used to calculate the principal stresses and their orientation, defined by the angle theta, shown in the picture in the middle. The principal tensile stress is sigma 1, and the principal compressive stress is a sigma 2. Using CSFM, the strain in the same element is depicted in the picture on the right. Concrete compresses along the direction of sigma 2, generating the stress field sigma C2. Since concrete cannot carry tension, the transverse tensile stress, sigma 1, is not transferred by the concrete, resulting in a crack perpendicular to this direction. Consequently, the tensile stress sigma C1R equals to 0. To prevent the failure, all tensile stress must be carried out by the reinforcement, in this picture indicated by the blue lines. Which is why I have mentioned that the reinforcement must be included in the model. And if we look at the basic assumptions, they can be summarized into these points. The method is based on the finite elements. The loads are applied in increments to the model with nonlinearly defined materials, and as a result, we get continuous compression fields in concrete and tensile or compression stresses in the reinforcement. This method covers both ULS and SLS for the 2D. For 3D, only ULS so far. And now, the CSFM, we have added this 3D model type in detail, and we just augmented the standard CSFM into third dimension, resulting in 3D CSFM with triaxial stresses considered. The triaxiality is considered with the Moore-Coulomb theory of plasticity, which you might be familiar from your studies. This method is suitable for brittle materials, therefore suitable for concrete as well. And we have further modified the assumption of this theory in two ways. Firstly, since in tension the concrete is neglected, we have performed a so-called tension cutoff. And secondly, the angle of internal friction, phi, is conservatively appointed as 0. And the practical impact of the triaxiality, or in other words, confinement effect, is that when a concrete element is exposed to compressive stresses in all three directions, the load-bearing capacity of concrete increases. So here is the Moore-Coulomb model, which can be found in the 3D CSFM method. We see the tension cutoff on the left, and the blue line demonstrates the linear Moore-Coulomb plasticity envelope. And the practical consequence of introducing a 0 angle of internal friction is that the maximum possible difference between sigma C3 and sigma C1 remains constant for any value of sigma C3. And the value of sigma C equivalent, in other words, equivalent principal stress, can therefore be directly compared to the uniaxial compressive capacity of concrete defined by the standards. And it is independent of the maximum value of sigma C3. Well, as it is a standard for the methods implemented in IDEA StatiCa applications, the method is verified. The method has been compared with experimental results from lab and with models created in scientific tools such as Abacus. In these graphs, we can see the results for anchors of 3 different lengths with the same diameter. Blue color representing the experiment, green Abacus, and orange 3D CSFM, with the 3D CSFM being most conservative. And the yellow color represents the design values, showcasing that according to the code values, we have significant safety buffer in our designs. Right, I've came to the end of my first end of my presentation. Adam, back to you.
Thank you, Dominic. Thank you for your thorough micro lecture on this topic. And now we will pass the word directly to Ondřej, right? Who is ready with his live demo of the complete workflow? Am I right?
You're right, Adam. I'm ready. You should already see my screen, as you can see.
Yes, I do. So the floor is yours.
Thank you for the confirmation. You can see I start in the connection application. There is a column with a base plate attached to the concrete block with 4 anchors. The column is placed eccentrically near the edges of the concrete block, and also the loads are asymmetrical. It's loaded with a compression force and a pair of bending moments. So we get tension in these 2 anchors near the edge of the concrete. And you can see they are both red, meaning the code checks are exceeded. And when we look at them in more detail, we can see the problem is not the tensile resistance of the anchor itself. It is the concrete breakout which is governing in this case. So we don't want to solve this problem by making the foundation bigger. So we want to take the reinforcement into account. For this, we have this nice button here, and we just name the file in detail that will be automatically created by this export, and it will be opened in a short while. Yeah. As you can see, this is our block in detail application. The user interface is almost the same as in the connection application. The top ribbon, tree menu, the property grid, and we are by default in the design tab. We can look in the other tabs as well. Here in the project tab, you can name your project. Here you can see the code settings. You can see there is the Euro code. It is now the only available code, but the American codes are under development and will be ready for the release of the next version in the spring of 25. We can check the materials. They were all exported from the connection application. So there is the concrete for the concrete block, reinforcement, the material for the anchors, and the steel material for the base plate as well. Going back to the design tab, you can see here you get a warning about reinforcement. This is another way the application warns you that this method is really only applicable for reinforcement, for reinforced concrete. So you have to input it. We can start now. We can go through the individual items in the 3D menu, starting from the top. Here I would change the default concrete cover to 45, and we can see there's the member completely taken from the connection application. We don't have to change anything here. And now I will jump to support. As you can see, by default, the surface support is applied to the bottom surface, as we assume it is a footing, and it is applied to the whole surface. Alternatively, you can change this to a small area defined by a polyline. You can edit the stiffness of the surface support in each direction. And for the Z direction, you can see here a small icon, which means when clicked, the support works only in compression. Usually for a footing, it is the case, as the soil spring can only be active in compression. But you need to remember that you always have to check the stability of the whole foundation. So you have to do this, and in the detail application, it's always recommended to check the deformations to be sure the model behaves in an expected way. It's also possible that you don't model footing, but a part of the larger structure, and you indeed want the support to be active in tension as well. In this case, it is important to remember that even though the support is active in tension, the concrete attached to it is never. So you need to input the reinforcement in a right way. I will show you what I mean by that. let's start with inputting reinforcement. Here you can see how it's done. Just 7 of them, the distance of the layers. So, and now let's take a look from this side, and I will change the anchorage type to continuous. This means the reinforcement continues outside of our modeled block, and the tension, if it exists in this part of the support, can be transferred through the reinforcement. Another member which was completely imported from the connection is the base plate. The thickness of material is already defined. Here we can define the mechanism for shear force transfer. Again, this friction was already set in the connection application. There are other options. It can be transferred through a shear lock or through anchors. And there is a default value of friction coefficient, which checks if the compression force is sufficient in relation to the horizontal forces. And now let's move on to the anchors. As you can see, there are 4 of them, and you can change here if it is an adhesive anchor or a cast-in-place reinforcement. Diameter material already defined. What you need to define here is the bond strength. As you can see, for a cast-in-place reinforcement, you don't have to define the bond strength, as it can be calculated directly from the code formulas. But for the adhesive anchors, it has to be taken from the technical approval of the manufacturer. Dominic will talk about this later in more detail. Just to remember, this is the designed value, so the factors are already applied when inputting this number. And then there are these 2 important checkboxes. I would like to remind you that the base plate and the anchors are modeled separately in the model. It is for the reasons of generality, it allows us to define multiple base plates, multiple anchors that are or are not connected to a base plate. But it also means that we have to define how the anchors are interconnected with the base plate. So in case of the shear, it for instance allows us, when the shear transfer is set to anchors, we still can define which anchors will transfer the shear. For instance, the code may require that all the shear is applied only to these 2 anchors near the edge of the concrete. So we can do this by unticking this checkbox for these 2. And then there is the transfer of axial forces. You may be surprised that this is unticked, but I will show you why. It has to do with how the loads are exported from the connection application. Dominic already touched on this. What you get after the export are the forces calculated from the stresses in welds. So those are these forces you can see at the outline of the cross section. And then there are these 2 forces. One is acting on the anchor itself, and the other one is there for the reason of equilibrium, and these two components are not interconnected. You can see the force is exactly the same value as it is in the connection. And when we modeled it this way, there will be no discrepancies in the anchor forces. It's important because there is a difference between the models. In the connection application, you have nonlinear material for the base plate, and there is also a portion of the column modeled, which is not here in the detail application. So again, this is the way how to ensure that the forces in anchors are exactly the same as in the connection. This is the one imported load case. We can add a new one if we want to. We can take cell weight of the concrete block into account. This could help us with the stability if there's a problem with it. And we can add it to the combination just like this. The ULS combination is actually what's analyzed during the calculation, not the individual load cases. So the last step is to define the reinforcement. I can use this group I already defined, just edit it a little. I will add here the fourth line, and I will change the anchorage type. It can be either the perfect bond to simulate the stirrup, or we can have hooks on both ends. So I can leave this like this. And now I can copy this group, and just by simply changing the surface, I get the reinforcement in another direction. There's a useful trick. You can uncheck the rebars here, and then only the highlighted group will be displayed. This way you won't get lost when there is already too much reinforcement in the model. You can copy it once more. This will be the horizontal reinforcement. So let's input it like this, and the part apply to the horizontal surface. And the last group of rebars we need to define are the stirrups. They are not on surface, but on one surface edge, and it will be the surface 1, edge 2, that is the vertical one. Now let's set the distances. And we need to position them in the right place. So now they are in the right position, and I will change the anchorage type once more to the perfect bond. This way we can model that each of these rebar is actually a vertical branch of a stirrup. So now when the model is complete, we can calculate it. One more trick I will add for this here in the mesh settings. You can change the default value to a higher one, like for instance 2. It will speed up the calculation, and because it usually takes some time, this way it will be faster. And when you check the results and you are sure you input everything correctly, you can go back, change this to the default value, and run the final analysis. So So let's click calculate. I already prepared the calculated model, so we don't have to wait for the results. This is the window you will see after the calculation is complete. These are the summary results. It's like all in one. Here at the top corner, you can see the green check marks. It's always a good sign. Means the stresses are all below the bearing capacity. And we can go through the results in more detail. You can display the equivalent stress in concrete. Here you can see it on the surface, but it's also possible to define a section, so you can take a look what's happening inside of the concrete as well. You can check the stress in reinforcement. So this picture quite nicely shows that the tension from the anchors is transferred to the neighboring reinforcement bars. We can check anchorage as well, showing us the bond strength. And there are also the auxiliary results. I already recommended you to always check the deformation, so you can be sure that the whole block doesn't turn over or move horizontally somewhere. So this is Jordan. And the last thing, we can take a look at are the stresses. You can check all the main stresses, all three of them, not only the equivalent. And the nice picture about how the structure works is here, where you can see the direction of the stresses. So here you can see how the compression is transferred through the block, and how the tension from the anchor is transferred through the struts into the neighboring reinforcement. So when that's all done, you can even generate a report. As always in our applications, you can select what will be included in the report, and upon clicking the generate button, you will get this nice PDF where there's all the inputs are summarized. You get the pictures of the stresses and the important code checks. So with this, I would conclude the practical demonstration, and Adam, it's yours once more.
All right. Thank you, Andrzej, for this demo. What I will do is I will pass the word directly to Dominic back. So, Dominic, are you ready to tell us something about the correct approach in modeling such anchoring details or anchoring models in Detail App? Give us some tips and tricks.
I am, Adam. Or
Go
maybe I will pass the word back to you and you back to me.
Okay, go ahead. I can't wait.
Okay. All right. Thanks, Sandra, for the practical demonstration. Let's have a look what to keep an eye on during the modeling. There. So the setting of the anchors and how to define the anchors in StatiCa connection. You can define the anchors by the type of the anchor, with the geometrical shape and type, the anchor type, and the shear transfer force can be transferred with three devices: friction, anchor, or a shear lock. There are two types of anchors according to the installation. The first is cast-in, or otherwise known as pre-installed anchors. They can be further divided into three types: the straight anchors, anchors with hooked end, and finally anchors ended by a washer plate. The second type of anchors according to the installation are the post-installed anchors. They can be either adhesive or mechanical. However, mechanical anchors cannot be found in connection application. Only adhesive anchors can be designed in connection and detail. For adhesive anchors, the technical specification of the anchor manufacturer must be used. The default value is set to 5 megapascals. So when the straight or hooked anchor is set in connection application, they are exported into detail as the following. The straight anchor is exported into detail as adhesive anchor with a default bond strength of 5 megapascals. This is a design value, be aware of that. The hooked anchors are exported as pre-installed reinforcement rod with a standard band according to the code. In detail, there are more anchorage types. They can be further modified after the export. Let's have a look at them. First, we see a straight anchorage type with a beta factor of 0, and then there are hooked, bended, and looped anchorage types with a beta factor of 0.3. And then finally, perfect bond, perfect bond and continuous bar. And I have skipped this one. This is a welded transverse bar with also a beta factor of 0.3. Notice that there are only 3 beta factors. That is because of the code, which only states only these 3 values are available. You can modify it in the property grid. The that I already mentioned many times, and Andre as well. You can find an article on our website in the support center, which I strongly recommend. And this article describes where to look for the values and any anchor manufacturer's materials, which you will then later type on into this bracket. I would like to also talk about the transfer of loads and its devices. The load can be defined either to the anchor directly, and in this case, the load is transferred to the concrete directly. The tension, the compression, and the shear as well. On the other way, when the load is defined on the base plate, you can select which anchors are used to transfer the loads. And as you can see, you can set the interconnection of individual anchors with a base plate. This is important, especially for shear transition. Shear can be transferred via 3 transfer devices. Firstly, the friction between the base plate and the concrete surface. Anchors do not act in shear in this case. Secondly, via anchors. And lastly, via a shear lock welded to the bottom of the base plate. Interaction of these devices for shear transfer is not possible. They can only serve in one way, second, individually. And finally, here I have an explanation. I have a similar use case as demonstrated by Andre in connection. And I have said it that for the shear transfer, I will only use this highlighted anchor and the anchor that we cannot see. And in this anchorage close to the edge, with the shear force acting in the direction outside of the block. And you can observe the deformed shape, and as it would cause the pull-out of the concrete edge, which does not happen because the stress is captured by the reinforcement. This is already a screenshot from StatiCa detail. And the pull-out of the concrete edge does not happen. Why? Because the reinforcement is utilized, and notice that only the anchors that I have specified are utilized, the other two are not, and they are marked by the green color. And finally, in the last picture, we can see the equivalent principal stress under the base plate. A lot has been said. So I would like to ask Andre, Andre, are you there?
Of course, I'm here with you, Dominic.
Awesome. So please, can you summarize the workflow of the export from connection to detail application?
Of course, I can do that. So just quickly go through all the steps of the procedure I already showed. So the first step is to model the anchoring in the connection application and export it to detail. There, you should always check the support, and if it's a compression-only support, you have to be aware that you need to check the possible turnover as well. Then it's always mandatory to design the reinforcement. This should be done according to the standards. There are requirements you are probably aware of. For adhesive anchors, you need to define the bond strength. It was talked about many times during this webinar, and it is always necessary to check the transfer mechanism for shear loads. There's a checkbox for that. You can run the analysis. At the first step, you can change the mesh multiplier, and when you check the results, that's the 7th step, you can go back to the 6th, change it to the default value, and run the analysis one last time. And when everything's ready, the last step will be to generate the report. So that's the whole procedure. And now let's talk about the future of the method. What we showed you is the first use case, but the 3D CSFM method is general, and in the future it can be applied in many more use cases, some of which you can now see on your screen. It can be some bridge diaphragms with pre-stressing, the anchorage zones in pre-stressed constructions. It can be the punching shear in slabs, and the middle part there you can see a pile cap. The pile caps are currently being verified and validated, and for the release of the next version 25 in the spring of next year, there will be fully available to you as well.
All right. Andre, thank you for this further info. And ladies and gentlemen, we're getting to the end of this webinar. So I'm taking the word again. And I have one more question for you, one more poll. The question is, if you would use detail after seeing this demo, after having just heard all the information and so on. So It's easy. Is this a attractive application for you, and would it help you to solve your problems when designing anchoring? Dominic, what do you think? Have we convinced our attendees today?
I can't speak for them, but I have convinced myself, and so did Andre. So, like, I definitely would.
Very good, very good. All right. Still, the voting is going on. 3/4 of our attendees have voted already, so let's wait a few more seconds and I will close the poll. And I will share with you the results, and that's this. All right, that's looking very good. Thank you. Thank you for this. Means it's promising that what we have developed will find use. That's good. All right, I will hide this poll and I will take the presenter and conclude this webinar. So I'll just jump back to the presentation, and there is the questions and answers section. So you have sent a couple of very good questions. Thank you for that, and I will try to read and answer some loud now. So there is a question, is the Australian code checks in development as well in detail for the 3D solution? Dominic, do you have any information about that?
Well, the first one to follow Eurocode will be ACI code, the American code, and then there are others that will follow, but the Australian code at the moment is not in the development.
All right, thank you. So that means a matter of at least a year, let's say, in the version 25.1 maybe. All right. A second question is about, is there any validation, calibration of results in relation to experimental tests that could prove the effectiveness of the application? And there was also another question about the theoretical background or so. The answer is yes. Dominic has presented this, and I will show you also where you can find this information. So if you go to the webpage ideastatica.com, you go to the support and learning section, click here, go to the support center, and here you can find at first the theoretical background, that is here, detail and 3D solution. Here everything is described, so also how the reinforcement is treated, etc. And the verifications, if I go back, they lay just next to theoretical background. So here, if I go here and filter detail 3D, I can see also the verification documents, and you can go through them, read all on your own. All right. So that was the second question, and let's go back to the list. Question number 3, is it possible to add a gap between the base plate and the concrete block, or the gap filled with grout, or so-called the mortar joint? Dominic, can you comment on this?
Yes, I can. So this is not currently available, and it will be available in the near future, latest in the version 25.0. That means April of next year.
All right, thank you. Another question for Ondřej. Can you use the software to check the connection between a steel element and a non-foundation type element? So for example, a steel beam anchored to a concrete wall.
Yes, of course, it is possible. It doesn't have to be a footing or a block. You can define the dimensions and so that it looks like a wall. You can reinforce it as a wall, and you can also set the supports accordingly. So it doesn't have to be the block doesn't have to be supported only at the bottom surface, but you can support all of them with continuous reinforcement taken into account. In this case, it's definitely possible.
All right, so there's pretty much variety in what you can model. I can show you some examples again, support and learning section, download, where you can download the sample projects over here. And again, if I filter detail 3D, you can see some examples, for example, a beam anchored to a concrete beam or a concrete column, a corbel, and etc. All right. Thank you, Andrzej. And another question. We are running out of time, so let's have one more. Dominic, can you model a base plate provided with a shear lock?
Yes, you can. Yes, it is available as I have it in a demonstration. We haven't demonstrated that directly in the application, but it is possible. Just in Idea StatiCa connection, model a shear log. There it is. And then it is transferred into Idea StatiCa detail, which can, by the way, also be used as a standalone application. You don't have to start in connection. You can start directly in Idea StatiCa detail application and model the block right over there. Yes, there it is. So the 3D model type needs to be selected, and then you can select concrete block, pad, or a wall, and carry on with your design.
Very well. Thank you, Dominic. All right. So thank you for our questions. Hope we answered them well, and we answered all of them in the chat. The ones that we don't have time to go through aloud now. One last information from my side is that if you cannot find this 3D solution in your detail app, and you have Idea StatiCa on your computer, that might be that it's not included in your license. And if you are interested to have it, we encourage you to contact your local reseller. How to find your local reseller? You go to the webpage again. Sorry. Go to company and contact local support sales. And here you find your reseller if you don't have the contact at hand. All right. We are at the end. Gentlemen, let's wave. Let's turn on the webcams if we haven't done so. No, we're still here. happy to just guided you through this webinar. So what to say at the last word? Thank you for your attendance today. This was the last webinar of this year. Hope you liked our new solution for anchoring in 3D, and hope to see you next year in some other following webinars, not only on this topic, but also other topics in our applications. Thank you very much and see you later. Gentlemen.
Thank you very much. See you next time.
Yeah, thanks, and have a nice rest of the year.
Bye-bye.
Bye.